Okay, let's look at number 32. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a processing plant is modeled by this. So, just a quick note, this is a rate, right? This is some sort of velocity function, always important. Okay, and that's the amount going into this processing plant, where T is measured from time 0 to 8 at the beginning of the workday. There is this. So they gave us a time 0, which is probably going to be important. So we know that at time 0, there was already 500 tons of unprocessed gravel in the plant. Then during the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. So think about what's kind of going on here. Just to be clear, we have two things that's going on here. So imagine this right here represents the amount of this picture right here is gravel, right? This is the gravel being put into the plant. Okay, that's the G of T function. Then you can kind of think of the constant 100 tons. That's kind of leaving. I'm not going to say it's leaving because we don't know if it's actually leaving the plant, but it's being processed. So something's happening to it. So in other words, this pile or whatever, it's leaving that pile. Hopefully that makes sense. Okay. Let's move on to letter A. Find G prime of 5. Using correct units, interpret your answer in the context of the problem. So first off, note, G of T is already a rate of change, right? So G prime of 5 is going to be a rate of change of a rate of change. So we just have to take note of that. So I'm going to say, and this is a calculator question, so I'm going to say G prime of 5, and I totally do this on my calculator. There's nothing really to show here. I get negative 24.587 or that's terrible. Or negative 24.588. And our units, right, are going to be tons per hour, right? Because it was originally the rate, the units were tons per hour, but now we're taking another derivative, so we're dividing by hours again. Okay, so now let's go through, and what did they ask us to do? They said, using correct units, interpret your answer in the context of the problem. Okay, so I just have to kind of summarize now at what this is saying. So I'm going to say, at time t equals 5, the rate at which gravel, I didn't spell which right, at which gravel is entering the plant, right, or arriving, I guess, is arriving at the plant is decreasing by 24.587 tons per hour. Okay, now couple notes on that aside from the fact that I spelled arriving incorrectly. One, I've done a couple things in my explanation. The first thing I've done in my explanation is I've said that it is decreasing. I have taken care of the negative sign, okay? Second, by using the word decreasing, I'm saying I'm taking this rate of change and I'm taking a derivative. Remember, increasing, decreasing means derivative. So I'm saying this rate of change, so it's really important. The rate at which gravel is arriving is decreasing, right? So derivative. And then I gave my units. Let's move on from A. Okay. B. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. Okay, so they're just asking us how much unprocessed gravel arrives during hours of operation. They're not caring about the processing at all here. So what I'm going to do is I'm going to take how much was already in there? So I think you would agree at time 0, right, there was already 500 tons. But then I have to add to it the displacement from hours of operation, which are 0 to 8, of g of t dt. Okay? Again, this is a calculator question, so what I end up getting is I get 8 to 5.551 tons. Okay? Let's move on to letter C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5? So is the amount of gravel increasing or decreasing? Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5? Show the work that leads to your answer. Okay, so let's see here. Notice, and I'm just going to I'll highlight this in pink. This is the amount of gravel that's being processed per hour. If the amount of gravel, let me just make sure. If the amount of unprocessed gravel is increasing, right, then at time, what was it? At time t equals 5, then that number would be larger than 100, right? So for example, if 110 tons per hour of gravel are being unprocessed at time t equals 5, are entering the plant at time t equals 5, but 100 is being processed, then 110 is larger than 100, therefore that amount would be increasing. On the other hand, if it's less than that, right? So like, for example, if it's 50 tons are entering, but it's being processed at 100 tons per hour, then the amount is decreasing, because you can imagine the pile is slowly decreasing, right? So basically what I want to know is the amount entering greater than or less than the amount leaving? Okay, the rate of change of the amount leaving, I guess we could say. So what I'm going to do, hopefully that makes sense. The amount being processed is greater than or less than the amount, the process rate of. Let me write it down, and hopefully that makes sense, and then I'll try explaining what I said, because words are not working for me right now. So what I'm going to do is I'm going to find out what is G of 5, because G of 5 is going to represent the rate of change of gravel being processed, right, at time t equals 5. So G of 5 equals 98.147, okay, or 98.148, okay. That's the amount, that's in tons per hour, that's the amount arriving. Now the question is, how much is leaving? Well, it's 100 tons. So I think you'd agree this is less than 100 tons. So since the amount being processed is greater than the amount arriving, then the amount in our pile is decreasing. So what I'm going to say, I know that's a little awkward, but hopefully the way I say this is a little more solid. So what I'm going to say, since the rate in which gravel arrives at the plant is less than the rate at which it is processed, right? Except for all the S's, is processed, then the amount of gravel must be decreasing, right? So again, imagine a big pile of gravel. At time 0, there was 500. At time 5, right, you've got this stuff coming in and you've got this stuff leaving. But because more is leaving than coming in, that pile is shrinking. And that's kind of what we said there. Okay? What letter was that? That was C. Let's move on to letter D. And I'm going to grab D. Okay. Let's put it right here. Okay, what is the maximum amount of unprocessed gravel at the plant during the hours of operation? So here's what I'm going to need to do. In order to determine the amount, the maximum amount, right? What I'm going to have to do is, first off, what is the amount of gravel at any time? Well, the amount of gravel at any time, I think you'd agree, well, we start with our 500 at time 0, and we add the amount that is arriving. So from 0 to, I'm just gonna call it T. I'm just kind of, don't worry so much about these pieces because I'm not really, well, I am kind of going through it. This right here, this is how much is going in, and then how much is being processed is 0 to T of 100. Okay, so again, let's think about what we have here. Think of this as a brand new function. This would represent the, can I move this? Come on, allow me to move it. There we go. That's going to represent the amount. So I'm just going to call that A of T. So A of T, this is the amount that's kind of going in at any time, or this is the amount that's going in. This right here is the amount leaving. So if we subtract those two, that gives us the total amount at any time. So what I want to do is I want to take the derivative, but in order to find critical values. So what I'm going to do is I'm going to first off, I'm going to go, when does A prime of T equal 0, right? And that equals 0, I think you would agree, when, so if I take the derivative of the first one, I get when G of T minus 100 equals 0, right? I just took the derivative of that. Again, I don't really need to show all that, but I'm just kind of want to make sure you guys understand. So that's really occur. So when I plug that into my calculator, I get that occurs when T equals 4.923 or 4.924. So those are my critical values. Now, in order to evaluate this, though, I think you guys would agree, I need to look at my endpoints also. So I want to know at time, let's say, I need to know what is A of 0, A of my critical value, 4.923, and then my other endpoint, A of 8, okay? At A of 0, we are told there's 500 tons. At A of 4.923, right, if I plug that into my calculator, I get, so just to kind of, just to show you what I'm doing, just to make sure you guys get what I'm doing, this is going to be the integral 500 plus 0 to 4.923 of G of T. I guess, yeah. I know there's a little bit of like weird variable stuff between that and what I'm doing, but please understand, that was only because I was going to be taking a derivative of this function. So this G of X function was representing something a little bit different. I know it was kind of a little weird there. Don't get caught up on the variables, please. Okay? Because this was really just part of my explanation to you guys. This stuff up right here was really just part of my explanation. I probably wouldn't have shown it. What I would have shown was I would have shown from below that line, right? Just I'm finding a critical value and I'm testing endpoints. Okay, sorry, got a little bit distracted there. And that's going to be minus 1, the integral from 0 to 4.923 of 100 d of t. When you do that, you get 635.376. And then finally, I have to do G of 8. And let me move that down. Or sorry, A of 8. A of 8 is going to be equal to 500. It's the same idea, but we're going to go from 0 to 8 of G of t dt minus 0 to 8 of 100 d of t. Okay, plugging that into my calculator, I get 525.551. And the question was asking, what is the maximum amount of unprocessed gravel during the workday? And that maximum, so the maximum amount is, they were asking for a maximum amount, and that was 635.376 tons. Okay, that is problem 32. But just before I 32, right? Just before I leave it again, the big thing from here, what do we have to do? We have to find critical numbers, and we have to look at endpoints. And again, the amount of, we already talked about the amount of gravel in the processing plant. You have to look at how much is going in minus how much is going out. Again, that is problem 30.